Children, before going to solve this sum, that is 15th sum in the exercise, we must know how to find the height of an equilateral triangle. Already you have seen in the previous sum. You see, children, here. So, here ABC is a equilateral triangle in which AB is equal to BC is equal to CA. All are of same length, that is A units and A units. The height is nothing but AE is a perpendicular. So, perpendicular that is AE. So, to find out the length of AE, see children here, when we draw a perpendicular from a vertex to its opposite side in an equilateral triangle, the perpendicular bisects the side. That means, that is, if BC is A units, that is AE is perpendicular, it divides BC into two equal halves, that is, let the DE is the point where the perpendicular reaches, that is BE is equal to EC, that is BE is equal to half of A means A by 2, EC is also equal to half of A, that is A by 2. So, in the triangle ABE, angle E is equal to 90 degree. Therefore, so we can apply Pythagoras theorem. When we apply Pythagoras theorem here, it becomes, that is, AB square is equal to AE square plus BE square. Okay. So, AB square is A units, that is A square, is equal to AE, we don't know, that we have to calculate AE square plus BE square is equal to A by 2 whole square. Now, you do one thing, keeping AE here only, you send this AE A by 2 whole square to the left hand side of equals. Then what it becomes, you see, that is A square minus A by 2 whole square is equal to AE square, or this can be written as AE square is equal to A square minus A by 2 whole square, isn't it, children? So, here keeping AE square here only, A square means A square only minus, if you apply square to both numerator and denominator, it becomes A square is A square divided by 2 square is equal to 4. So, now it is subtraction of fractions. We have to take LCM, children. So, if you take LCM, what is LCM here? 1 and 4 is, 4 itself is a LCM. So, you have to divide this LCM from the denominator. 1 how many times? 1 4s are 4. 4 into A square is equal to 4A square minus 4 how many times are 4? 4 1s are 4, 1s are 4. 4 into A square is equal to, that is 4 how many times are 4 1s are, 1 into A square is equal to A square. That means, you see children here, that means you have to take away 1A square from 4A square, then it becomes 3A square divided by 4. What it is? AE square is equal to. So, then AE is equal to square root of, AE is equal to square root of 3A square by 4. Now, you see children here, if you apply square root to both, it becomes what? That is square root of 3 into square root of A square divided by square root of 4. Square root of 3 we don't know, keep it as such, that is equal to root 3 into A square means a square and the root they get cancelled. What remains? It is A divided by square root of 4 is equal to 2. Clear, children? So therefore, it can also be written as A into root 3, A by 2 into root 3. This can also be written as A by 2 into root 3. That means the height of the equilateral triangle AE is equal to A by 2 into root 3. A by 2 into root 3. So this you have to remember. So while finding the solutions or while proving this, we need the measurement of the height of the equilateral triangle. This is how we can find this. Okay, children, you take down. In the examination, no need to write this one. It is just for your understanding. I have explained here. This part, just we need this one. Means what is the measurement of the height of the equilateral triangle. That is AE is equal to A by 2 into root 3. That's enough. Okay. Thank you, children. Now, children, we shall take up the next sum, that is 15th sum in the exercise. What it says, you see here, in an equilateral triangle ABC, D is a point on the side BC such that BD is equal to 1/3 of BC. 1/3 of BC. Prove that is 9AD square is equal to 7AB square. So what is given here? First of all, it is equilateral triangle. You know that in an equilateral triangle is a triangle in which all sides are equal. So I have drawn the figure according to the statement. Here the triangle ABC is an equilateral triangle. Let all the length of the sides be equal to A units. Okay. Next, D is a point on BC. D is a point on BC. You see here, according to the statement, I have drawn the figure here. That is, D is a point here. Equilateral triangle ABC in which all sides are equal. Let the side be A units. Okay. So D is a point on BC such that is the length of BD is equal to 1/3 of the BC. Clear, children? So 1/3 of the BC. So now according to the statement we have drawn the figure. According to this figure, so I have written here the data. That is, in the triangle ABC, all the sides are equal because it is an equilateral triangle. That's what I have written here. AB is equal to BC is equal to CA. Okay. Next, BD is equal to 1/3 of BC. 1/3 of BC. These are all the things given. What is to be proved? That is 9AD square is equal to 7AB square. We have to prove. So as such, it is not possible to construct by just using this figure, children. So for that reason, I have drawn the figure here, another figure. So in the examination, you write this one, not this one. You don't write this one. Just to make you to understand, I have written this figure. Okay. So in the construction, you see, I have joined AD and draw AE perpendicular to BC. AE perpendicular to BC. So one thing you have to remember, children, whenever we draw a perpendicular in an equilateral triangle, it divides the side into two equal halves. Suppose, so BC is equal to A units, then, so let us consider this is E, that is, this one is half of A, this one is also, that is B is equal to half of A, and EC is also half of A, that is A by 2. Clear, children? That means a perpendicular drawn in an equilateral triangle to its opposite side bisects the side. Bisect means equally it divides. That is BE is equal to EC. That point you have to remember. Okay. Proof, let us see. So AB is equal to BC is equal to CA. AB is equal to BC is equal to CA. Let it be A units. Okay. Now what is given here? That is the BD is equal to 1/3 of BC, but BC is equal to A units we have taken, children, here. That's what I am writing here. That is BD is equal to 1/3 of BC is equal to A units means 1/3 of A. Clear? So then if BD is equal to 1/3 of A means how much part remained here? It is 2 part remained, isn't it? So that is DC is equal to 2/3 of BC. Then DC from here to here it is 2/3 of BC. So this can be written as DC is equal to 2/3 of BC is nothing but A units. So it can be written as 2/3 of A or 2/3 of A. That is DC is equal to 2/3 of A. Now since AD since AE perpendicular to BC, since AE perpendicular to BC, then BE is equal to EC. BE is equal to EC because exactly it divides equal parts, so it is half of A. That is BE is equal to EC is equal to half of A. That means we can also write it as A by 2. Clear, children? Okay. So next, in the previous video you have seen that how to find out the height of an equilateral triangle. Then what is the height of an equilateral triangle also you have seen. So by using that, AE is equal to, that means AE is what? The perpendicular or altitude or height of the equilateral triangle is equal to A by 2 into root 3. A by 2 into root 3. That is nothing but height of an equilateral triangle. Height of an equilateral triangle. So now you see, children, here the length of DE is equal to BE minus BD. The length of BE is equal to length of DE is equal to BE minus BD. BE minus BD. So what is the length of BE here? BE is equal to A by 2, isn't it? Minus, what is the length of BD? BD is equal to 1/3 of A. So simplify this. So whenever you simplify in this, you have to take the LCM. So because this is addition of subtraction of fractions, you have to take LCM. What is LCM of 2 and 3 is nothing but 6. So whenever we simplify it, it becomes, you see here, that is 6 is the LCM. So from 2 you have to divide 6 to how many times? 2 3s 3 into A is equal to 3A minus, here it is minus. So 3 is in the denominator. What is LCM here? It is 6. 3 how many times are 6 here? So 3 2s 2 into A is equal to 2A. Now what we got in the numerator? It is 3A minus 2A divided by 6. That is what? This is nothing but the length of length of DE. Clear, children? So length of DE is equal to A by 6. Now you consider the triangle. Consider the triangle ADE. In the triangle ADE, angle E is equal to 90 degree, isn't it? So whenever you see a triangle which is having a right angle vertex, you can apply Pythagoras theorem. According to the Pythagoras theorem, in the triangle ADE, AD is hypotenuse and AE is the perpendicular side and DE is the base. So according to the Pythagoras theorem, by Pythagoras theorem, so what it becomes? That is AD square is equal to AE square plus DE square. But what is AE square is equal to? AE is equal to? AE is equal to what? That is, yeah, AE is equal to A into root 3 divided by 2. That is nothing but the height of the equilateral triangle. Plus DE is equal to 6 by A by 6. DE is equal to A by 6 whole square. So whenever we square it, what it becomes, you see, A square means A square into root 3 whole square. Root 3 whole square means it is root 3 into root 3 is equal to square root of square root 3 whole square. Square root 3 whole square means the square and the root they get cancelled. What remains? That is nothing but 3. So therefore, so root 3 whole square is equal to 3 divided by 2 square means 4 plus here it is A square divided by 6 square means it is 36. Now we got A square into 3 divided by 4 plus A square by 36. Clear, children? So now once again it is nothing but addition of fractions. For that we have to take LCM. So LCM of 4 and 36 is 36 because 36 is a multiple of 4. Hence the LCM is 36 only. So LCM 36. So now how many times of 4 is equal to 36, children? 4 9s are 36. 4 9s are 36. 9 is a quotient. 9 into 3, 9 3s are 27 A square plus, so 36 how many times are 36? 1s are 1 into A square is equal to A square. So in the numerator what we got? So 27 A square plus A square. You see, if you add 1 A square to 27 A square, together it becomes 27 plus 1 is equal to 28 A square it becomes. In the denominator it is 36. So what is in the left side? It is AD square. So AD square is equal to 28 A square divided by 36. Isn't it? So is it possible to divide 28 and 36 by a common number? Yes. Which is that? 4. From 4 we can divide 28 as well as 36. 4 7s are, from 4 we can divide, so 4 7s are 28, 4 9s are 36. So in the numerator what we got here it is 7, in the denominator it is 9. So what it becomes, children, here? It is AD square is equal to 7 by 9 A square it becomes, isn't it? So this 9 you send to the left hand side of equals, then what it becomes? So 9 into AD square is equal to 9 AD square is equal to what remains here? It is 7 A square. Did you understand? So 7 AD square is equal to, I have written as such in the next step also, is equal to 7 also I have written as such. But what is a square means? What is a here? So here in the triangle ABC, all the sides are equal. So I have taken a units. Each side is an a unit, isn't it? So that means in place of a is equal to what? A is equal to either AB or BC and CA, but it is asked here to prove 7b square. So in place of A, I am going to replace AB. I am going to replace AB. So in place of A, AB I have written. So A square means AB square. So therefore, we have proved 9AD square is equal to 7AB square. Clear, children? Did you understand? Okay, you take down, children. Now, children, we shall learn how to solve or how to prove the 16th sum. You see here, in an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitude. So what do you mean by this, children? In an equilateral triangle, here you see I have drawn an equilateral triangle ABC in which AB is equal to BC is equal to CA. All the 3 sides are of equal length. Okay. In this we have to show that the 3 times the square of one side out of these 3 sides AB, BC and CA, out of these one of the side, that is, for example, 3 times the AB square is equal to 4 times the square of the median, 4 times the square of the altitude, okay, altitude, AD. Okay. So this we have to prove. So according to the statement, figure is drawn. According to the figure, the data is written here. In the triangle ABC, you know that AB is equal to BC is equal to CA because it is an equilateral triangle. And the altitude they asked here, so AD perpendicular to BC it is drawn. Okay. So what we have to prove here? 3AB square or BC square or AC square. One of the side it is as 3 times the square of one side, either AB or BC or CA, is equal to 4 times the altitude, square of the altitude. Okay. Proof. You see, children, here in the triangle ABC, AD is the altitude, means it is a perpendicular. You know that in an equilateral triangle, the perpendicular drawn from the vertex to its opposite side bisects the opposite side. Bisect means it divides BC into 2 equal parts, that is BD is equal to DC. Clear, children? So since BD is equal to DC, the whole length is divided into 2 equal parts. So we can write this one as, that is BC by 2, BD is equal to BC by 2. Similarly, DC is also equal to BC by 2, half of the whole length. Clear, children? So AD bisects BC. Therefore, BD is equal to DC is equal to BC by 2, because it has divided the whole length into 2 equal halves. Children. So next, you see, now let us take this triangle. In the triangle ABD, you know that angle D is equal to 90 degree. Angle D is equal to 90 degree. So we can apply Pythagoras theorem, isn't it? So by Pythagoras theorem, we can write it as, that is, AB square, square on the hypotenuse, is equal to AD square plus BD square. Square of the hypotenuse, square on the hypotenuse is equal to sum of the squares of the other two sides. Clear, children? So here AB I am keeping as such is equal to AD also, but here the length of BD is equal to half of BC. Therefore, in place of BD, we can substitute BC by 2. Since it is having square, we can put whole square to BC by 2. Then what happens, you see, children, here? AB as such you keep it is equal to AD also, AD square plus. So if you apply square to both numerator denominator, the numerator becomes BC square, denominator becomes 2 2s are, that is 2 square means 2 2s are 4. Now we have to take LCM. If there is nothing in the denominator, so we can write 1 in the denominator. So this also fraction, this also fraction. It is nothing but addition of fractions. While adding the fractions, we have to take LCM. The LCM of 1 and 4 is 4 only. So now you see, or else we can do like this also. That is multiply 4 into this, that is AD square. That is 4 into AD square is equal to 4 AD square plus BC square divided by 4. We can write this. How you convert a mixed fraction into improper fraction, in the same manner here also this addition of fractions where one of the term is having a denominator 1. So in such cases we can multiply directly the denominator of the second fraction with the numerator, that is AD square. 4 into AD square is equal to 4 AD square plus BC square divided by 4. Here the division is there for only BC square, but here it is applied to both 4 AD square plus BC square divided by 4. Clear, children? So now you send this 4 to this side. Then what happens there? So 4 division becomes multiplication when it is sent to the left side of equals. Then what it becomes? 4 into AB square, that is 4 AB square is equal to 4 AD square plus BC square. Clear, children? Now in the next step, what I will do here, this BC square I will send it to left hand side of equals, to the left hand side of equals. So plus BC square becomes minus BC square. Then the terms in the left hand side become, you see, 4 AB square remains as there. If you bring this BC square plus BC square to the left of the equals, then it becomes minus BC square is equal to, on the right hand side what remains, that is 4 AD square. Okay. Now children, here in the data we have shown here the length of AB is equal to length of BC is equal to length of CA, because it is an equilateral triangle. All the sides are equal. So that means we can replace AB by BC or BC by AB. Clear, children? So therefore in the place of BC square, that is in place of BC, I am substituting AB, because AB is equal to BC or BC is equal to AB. So therefore if I substitute AB in place of BC, this term becomes BC square means AB square. Here it is 4 AB square minus, here it is nothing but 1 AB square. If you take away 1 AB square out of 4 AB square, how much remains? 3 AB square it remains. So in the left hand side 3 AB square, on the right hand side of equals, that is equal to 4 AD square. So this what has to prove here, that is 3 times the square of one side, 3 times the square of AB is equal to 4 times the square of one of its altitude. 4 times the square. We can draw 3 altitudes in this. We can draw altitude like this also or like this also. We can draw. But here we have considered only one, that is AD. Clear, children? If you want, you can prove this by taking AC as a base. Here I have taken BC as a base. If you want, you can take AC also base by taking BE as an altitude. Or you can also consider AB as a base by taking, that is, CF as altitude. Clear, children? So we can prove like that. Understood, children? Okay. Take down. Children, we shall take the last sum in the exercise, that is 17th one. So in triangle ABC, AB is equal to 6 root 3 centimeter, AC is equal to 12 centimeter, BC is equal to 6 centimeters. Then the angle B is. So there are 3 options are given there. In that, the first option is angle. The first option A is 120 degree. Second option B is 60 degree. Third option C is 90 degree. And the fourth option D is 45 degree. See, children, here. So the sides of the triangle are given here. We have to apply converse of Pythagoras theorem. Clear, children? So here you see the given sides AB is equal to 6 root 3, AC is equal to 12 centimeter, BC is equal to 6 centimeter. Now let us take the square of these. That is, AB square is equal to 6 root 3 whole square. That is, when we apply square to both 6 and root 3, 6 square is 36, root 3 whole square is 3 is equal to, if you multiply, it gives 108. If you take AC square, AC is equal to 12, so it is 12 square, that gives 12 square is equal to 144. Next, you see the third one, BC, that is BC is equal to 6 centimeter, BC square is equal to 6 square, so square of 6 is equal to 36. Look at this. Here AC is equal, that is AC is equal to 12, so square of that is 144. And if you take these two, the sum of these two is equal to 144. That is 108 plus 36 gives, isn't it? That means sum of AB square plus BC square is equal to AC square. That means 144 is equal to 108 plus 36. So 144 refers AC, that is 12 square, and 108 refers 6 root 3, and 36 refers 6, that is 6 square. So here the 12 square refers AC square, and 6 root 3 whole square refers AB square, plus 6 square refers BC square. That means AC square is equal to AB square plus BC square. The square on the hypotenuse is equal to sum of the squares of the other two sides. Or in the converse of that, the square on one side is equal to sum of the squares of the other two sides. Then the square, that is the angle opposite to the first side, is right angle. It is converse of Pythagoras theorem. So on the basis of that, so here the angle B is right angle. So therefore the given triangle ABC is a right angle triangle, right angled at B. Clear, children? So that means angle B is equal to 90 degree. Clear, children? So by converse of Pythagoras theorem, okay. So therefore, the correct option is, that is C, is equal to 90 degree. Clear, children? Okay. Take down, children. So work out all the problems in this exercise and 1 or 2 times, and if you have any doubts, you ask me. Clear, children? Okay. Take down.